All right. Good afternoon, everyone. Welcome. We're going to go ahead and get started. So happy September. I don't know where September came from. I really can't believe it's here already, but I hope everyone has had a good summer and staying safe and well in these very strange times that we're in. My name's Pamela Kaliski. I'm a senior measurement scientist at the American Board of Internal Medicine and the organizer for this session today. So thank all of you for joining our virtual session today. As you can see, it's titled Challenges with Automatic Item Generation Implementation, Recent Research, Strategies, and Lessons Learned. So I think I can speak on behalf of all of us who are presenting today that we think this is a very important topic. We think AIG has a lot of potential for our field, especially when it's done carefully and cautiously. So we are looking forward to sharing what we've been working on with you today. So it would have been great to see everyone in person in San Francisco, but we are grateful that we have these virtual platforms and we're still able to share our work. Definitely want to give a huge shout out to all of the NCME staff who made this happen. So all the conference co-chairs and all the staff who organized these Zooms, thank you so much for that. So let me just give you an overview of our session today. There's going to be 4 presentations today, about 15 minutes each, and then we will have discussant comments from Hollis Lai at the end. We'll do Q&A after that. So if you have questions and comments directly for the presenters, please hold them till the last 15 minutes and we will address them then. Now you're welcome to use the chat throughout, talk to each other, have conversations. Just know that the presenters themselves are not going to be pausing to answer questions as they're presenting because we do want to stay on schedule. And with that, please enjoy our session, and I will turn it over to Donna to kick us off. So I will stop sharing and pass it over to you. There you go, Donna.
Oops. Okay. We should be able to okay. I think we're there. It's amazing when this works, actually. Hi, everyone. My name is Donna Mitovanovic. I've worked at a couple of large testing organizations over my career, last 20 years or so. But I am now an independent consultant. So, but happy to share some of the lessons learned and implications for introducing AIG into your organization. It's not as simple as you think. It's not like we just license the software and then you it's ready to go. There's a lot of things to consider, and the lessons I've learned implementing it at 2 different organizations, I hope that you find some of these points useful. So first, I'm just going to talk about the talent considerations. So both teams that I have led in my career, 100 to 200 people, generating primarily high stakes testing content. So things to think about. Most in the organizations that I've led, they have been doing human generated item generation for a long time, one at a time, item authoring, I call it. And there needs to be quite a switch to thinking about, rather than a specific slice through the construct, to thinking about the content in a more broad and deep way to build out what we call these item models. So the focus is really for the team needs to shift from this narrow slice to more construct specifications, thinking about cognitive modeling, thinking about the breadth and depth of all of the content in a single construct and the variable components of those versus the non-variable components. Bringing evidence-centered design to the table, and it's not a given that the subject matter experts within the content organization necessarily have a background in evidence-centered design, so doing some training on that is required. And then just thinking about how learning and the design science aspect can be leveraged when building really effective item models. I'll share something with you When I introduced AIG, and both organizations are currently using it operationally to generate high stakes content, most often the subject matter experts would push back, saying that there's no way that the output of AIG would produce the same quality of items that a human could generate one at a time. So something that I've done many, many times is I've taken human generated items and AIG generated items, mixed them up, put them before a subject matter expert, and asked the subject matter experts to sort them into the two piles, the human generated and the AIG generated. And every single time the subject matter experts have cannot sort them accurately. So it just, that's the outcome of that, is just a really, they can't believe it until they see it, that the quality is indistinguishable between the two modes of item generation. So it's and then the other count,
Donna, it's Pamela. I think you're breaking up a little bit. It doesn't look like we can hear you. Donna, you're still a little bit choppy.
Um, the other thing you have to consider when you're implementing AIG operationally is all of the processes. So typically, the standard process that occurs, I'm not getting any of it, but I author reviews them. You either put them on a test directly or you pre-test.
So Donna, we are losing you again. Let's go ahead and maybe move on to the NWEA folks. We'll come back to you. Why don't you try rejoining one time, and let's see if that works. If not, we'll go ahead and move on to the NWEA folks, and then we'll come back to you and see if that helps.
Sure.
We'll give you a minute real quick, and then we'll keep going. Thanks everyone for your patience.
I think that I think it's back to NWEA could probably go over the content sharing.
Move on to NWEA?
Hopefully. Yes.
Okay,
yeah,
let's go ahead and do that.
I think that
that sounds good. We'll come back to you next time. So we'll go ahead and turn it over to Abby, Sarah, and Emily at NWEA.
Okay, this is Sarah Miller. I am attempting to share. Let me know once you can see.
We can see your desktop.
Okay. All right. And Abby, did you want to start with the first couple slides, then I'll take over?
Yeah, so we're excited today to actually be here to share just a little bit of the work that we've been doing at NWEA. And I think what you're going to see is this is perhaps a slightly different view than what is traditional. We have been doing some traditional AIG work to really help with the, our traditional processes of, item pool creation and make sure we're not hitting item pool starvation and really keeping robust item pools there and really leveraging the expertise of our subject matter experts. And Sarah's going to share some of our successes there. But we've also started really exploring the power of AIG to leverage the future. And I think Emily's going to share a little bit with you sort of the approach that we're taking for that. And then I'm going to come back and talk just a little bit about some of the opportunities and implications that can unlock. I think as Donna alluded to, this is hard sometimes in the field because even talking to folks about AIG seems like this big, scary new technology that people don't necessarily want to trust, right? Because it's a computer doing the work that we normally assumed humans would do, but I think all of us who are here have actually seen the power in doing that. And so I think what we're talking about is what could potentially be sort of a next step in leveraging that power and the opportunity of the technology and the learnings that we're all having in the field. So with that, I'm actually going to turn it over to Sarah and let her visit with you about what we've been doing and what we've sort of operationalized and how that's going.
Great, thank you. I am the lead content design at NWEA. So right now, I do a lot of the planning and work with our current AIG process and development efforts. So I wanted to share with you, this is a very high overview process when we're creating items using AIG. And the big thing here is the focus on the switch from the energy and the time spent at the beginning up front working on the item models and reviewing the quality of those item models from the traditional item development where a lot of that time is spent on individual items. So that's where we gain the efficiency and kind of what we're looking to do for AIG. Now, currently, how we write those models, we do use Excel, but how we write those models is we start with a static item. It may be an exemplar item or an operational item that we already have in our pool that we want to model off of. And we have a SME identify the variables. So identify the pieces of content that can be changed and still assess the same skill. And from there, those SMEs then define the variables. So basically this is creating a list of content that could go in place of the current variables. What that looks like in a working item model, or item model 1.0, our first attempt at item models, it looked like this, where you have the list of acceptable names to go into that item. And Excel uses the random number generator to randomly select a number, and whatever names associated with that then gets inputted into the item. And then also any of the variables that are dependent off of that also get updated according to that. So that happens a bunch of times, right? Each variable, each time that you generate the item, each variable gets a different selection, gets inputted into the item, and then ends up as your final unique item. In this model, it's very hard to kind of visualize because it looks very Excel. But here is our finished product then in our item editor. So that is after the item goes from the item model into the item model. But if you may have caught on to a couple things, there are some issues with this item model plan. And this is where I talk about kind of the efficiencies and how we improved upon our first attempt at AIG. One thing you might have noticed is that is a lot of work for a SME who's not used to maybe the Excel or item models in general to start from scratch each time. And something that we're trying to gain efficiency, this is kind of losing efficiency to do this. Another thing, and I glossed over this very fast when so that no one kind of saw it, but if anybody caught, the third step was then copying and pasting into item editor, which again is not ideal to copy and paste into the item editor. And our last lesson learned here is even after we got these items into the item editor, we had a lot of individual spots in the items where we still had to go in and edit and review and revise the items after they're in, which is not really ideal in the AIG system. So what we did then, I'm going to introduce to you, this is item model 2.0. So to solve for some of those things and increase quality and efficiency, we created an item model user interface. So this is a fully functioning interface where a SME can get in and they can create their own item model without starting from scratch in Excel. There's a place to create their variable list. There's a place to do answer keys. And this is kind of a sped up video for the purpose of this, but this is actually creating a whole item model and 10 items in a minute and a half time. So that just shows kind of the where we've kind of learned to create a more user-friendly and flexible system to create these item models. And I'm going to show you then, I'm going to point out a couple of the wins in that second item model. One is that we've built in accessibility. So now instead of the numbers having to be inputted in with an equation editor, in the user interface, the numbers automatically come in with the item editor and with the alt tags. So we have that automatic instead of having to get in each item. Also, there's some flexibility. Users creating the item models can pick different characteristics of number of characters allowed or character entry. And depending on their response, then the item model will create the list of acceptable answer keys and import that into the item model at the same time. And the last thing I'm going to highlight here is we were able to solve for the copy and paste issue. So the current user interface, it automatically generates a unique QTI code per item. And when you click the save button, it captures that QTI in a different code and creates a list of QTI that then we can upload into the item editor. Oh, as you can see right there, I was kind of highlighting a lot of kind of the fixes and the efficiencies in the actual process and the item model writing. But what that has resulted in is, of course, efficiency. We've seen efficiency not only on time and cost, both places, compared to developing to traditional. We've also seen higher and faster calibration rates. So our AIG development seems to become operational at a higher rate and a quicker time span. Last, we also have been able to predict the ability levels of items generated by AIG templates more accurately. So if we're trying to fill gaps in our computer adaptive assessment, we're able to use item models to get to those ability levels that we need items the most at. And it's kind of because of these successes in the traditional AIG development that we've done that we've been able to and excited to explore more innovative and more impactful uses of AIG. And that's kind of where Emily and Abby are going to come in next to talk about kind of some of those expanding beyond this traditional item development.
My name is Emily Bo, and I am a psychometrician from NWEA, and I am going to introduce you this AI-based AIG. So our proposed solution is basically to use AI to create item models dynamically to discover, compare, and extend items, rather than a manual process of creating item models in Excel. And we create graph database, which basically combine NLP and semantic information from curriculum items as basis to create item models. And here is an overview of our proposed system. It combines both machine learning and human intelligence. And I'm going to walk you through the top half of the diagram step by step by using a curriculum page with items. So after feeding the system with the curriculum page with items, our first step is to identify the item boundaries and structural elements of the items. So here is a graph representation of the visual elements of the curriculum page that we just saw. And the blue line here represents the vertical distance, and the green line here represent the horizontal distance. And we also have different shape of line to represent the spatial relationship between the virtual tokens. So by doing so, we are actually able to detect patterns that indicate an item-to-item boundary, as highlighted in yellow. And not only that, we can also detect the within item structure. So here we can actually separate the item answer choices from its item text. And not only we can identify the text, and the process also allows us to identify the equations and images. So let's zoom out a bit to see what this process actually is able to give us. It's able to identify the text and as well as the images like highlighted in green and the equations highlighted in blue. So and plus the process is also able to identify the content of the image, and then it actually converts into text for NLP to process. So in this example here, it's actually able to convert these images into food, plant, fruits, and banana. So now we know that text is not part of the answer choices. Now we can analyze the text further. So the next step is to use NLP processes to identify flexible elements in the items and element interrelationship. And we are going to use the second item in that curriculum page as an illustration example. And so we are going to use varieties too. So the first tool that I'm going to introduce you is something called CoRef, in short of co-reference system. So it's able to identify expression in the text that link to the same person or the same thing. So in this case, we know that Sarah and she, they refers to the same person. And also just and also just to remind you what the actual item is about, is basically Sarah has 2 apples and 3 bananas. How many pieces of fruits does she have altogether? So we identify Sarah and she, they are the same person. Next. And then we will also use some other tools like the word nets. So the word net is actually able to help us to identify words that is in close proximity to each other. So after stemming, we are able to understand that and identify that both apple and banana, they are a kind of edible fruits, and they are both a kind of fruits. So we know that apples, bananas, and fruits in this text, they're interrelated to each other. So they are the flexible elements in this item. Then we will be able to find some other words to replace them in its item model. So now we actually get all this information and data from various tools. Then we can blend all of them together and give us a proposed item model. So let's review what we have so far. So we know that Sarah refers to she and she refers to Sarah. So basically now, and then we also know that apple and banana, they are both a kind of fruits. And in addition, we also do the dependency parsing, which basically analyze the structure of the sentence. So by doing so, we actually know that for the second half of the text is a call to action text. So it has the task that the item asks the student to do, and how many is call to action. And fruits refers to apples and bananas, and she have is Sarah has. And all together is basically the actual action the item asks the student to do, which is to sum a list of 2 apples and 3 bananas. So by blending all of them together, now we have a part of proposed item model, which is a pronoun plus a singular possessive verb, and plus a list of edible fruits, with the structure of integer plus edible fruits and joined with a conjunction word. And then how many pieces of fruits does pronoun plus a plural possessive verb all together. So now what can we do next? That actually comes the most exciting parts. So we can then use them to compare with the existing item pools. And then we can also compare different curriculums. And we can also evaluate coverage of curriculum tasks for standards. So by doing so, we can actually enlarge the AIG construct to bring an even fuller structure of the item model for subject matter review. So next comes to Abby's piece.
Yeah. So I think it's important to note that we wouldn't be on this call if we didn't all think that AIG matters and offers some promise to us in terms of things like efficiency, cost, item pool refreshment. We definitely get some good benefits from that. But I think what we're really exploring in the longer term, how do we take that technology? How do we leverage what we're learning? I would say in a world of big data and NLP and AI and things like that, that are really telling us a lot about how to process information about the world and move it forward. And I think what we're actually doing is we're unlocking some potential for us to attend to things like equity and recommendations for educators in ways that we're not seeing today. And if you can go ahead, Sarah, I'll talk a little bit about why we think that is. So the world today is bigger than ever for our students, and curriculum is very, very much more diverse. So gone are the days of being able to, as a test publisher, sit down with 6 or 10 textbooks that were the typical textbooks with the typical pacing for a particular area of content and be pretty well assured that we were creating items that were pretty much the items that were in the world that students were going to experience. And what we actually see right now is most of our teachers are actually pulling resources from all kinds of places, and they're asking students to demonstrate skills in ways that we just can't sort of control and touch all of that as assessment developers. And the human cognition load that would actually take for us to ingest all of that and make sure we were covering that world is really, really difficult. And we've got a lot of focus right now on things like culturally responsive curricula to allow our students to come in and actually apply their funds of knowledge in ways that may be different than sort of our traditional paradigms. And unfortunately, what we've potentially allowed to happen as the world gets bigger and bigger is sort of this next slide, which is we know how to create items based on the world that we know. And what that's doing is that's actually cutting off our potential to be assessing students in the way that they are learning and experiencing in the curriculum. So what we're doing is we're designing and developing a way that actually is allowing us to ingest information about the curricula in the same way that students experience it, which is largely visually on the page, right? Students can look at all kinds of different items. If you want to go to the next page, Sarah, that are all aligned to the same standard. So this is a 4th grade operations and algebraic thinking standard. And these are actually different ways that different texts are asking students to engage in that. And if students are only engaging with 1 or 2 of these and never seeing or being asked to demonstrate skills against the 3rd way, and that happens to be the way that we historically tested students, what we're actually testing for those students who have never seen the item in that way is their ability to transfer information rather than to demonstrate their thinking and their knowledge against this particular standard. And so by sort of expanding our world and how we can look at this, we are actually opening up the world for our kiddos and for ourselves as developers to understand more about how students are learning, where gaps might be, and actually think about item generation in the context of being able to present students with the best item for them to demonstrate the skills. Because really what we want to get to, if you want to go to the next slide, Sarah, is a world in which every student who knows this material should have the opportunity to show us what they know and what they can do. And we shouldn't have to wonder if the way that we're asking the question is actually preventing them from doing that. And so by leveraging what we're learning in AIG and really sort of extending that domain, we think there's a lot of potential to sort of push ourselves forward and further as an industry to continue to attend to equity for all of our kids. So. Thank you.
Great, thank you all so much. Donna, are you back on? If so, you can jump back in and pick up where you left off.
Oh, okay, sure. Can you hear me? I've turned off my video, so you cannot see my incredible, ponytail that I have today. So,
yes, we can hear you very clearly.
okay, excellent. All right, let me see if I can get back in here. And what a thrill to listen to the previous presentation. Just really, let me. We have so much overlap between our thinking, and it's great to see. So, okay, so here's where I left off. Can everyone see this process implication slide?
Yep.
Okay, awesome. Okay, so I think I was on the slide when the audio was not working well, but thinking about there are embedded processes in place, just like you saw in the NWEA presentation, where subject matter experts are used to authoring, reviewing, finalizing content. And so you have to figure out, if you've got an AIG engine that's going to sit outside of your main content management system, you've got to figure out a way of how do you, first of all, interact with that system, and then how do you get the content back into your content management system. So in that second 2.0 that NWEA just had showed you, the QTI output then allows you to import that content into your content management system without significant effort. You probably still may need to do additional quality reviews of that content once it's back in your content management system. Ideally, the AIG engine should be integrated with your content management system in the perfect world, where subject matter experts come in. If they're authoring human generated content, they use that system. If they're authoring item models, they also use that same system, and there's no need to import QTI into from an external AIG engine. So the last process implication is about authentic data, and this really gets to that equity issue. There are lots and lots of authentic databases out there of real real scenarios that students have been engaging in around the world. And if you could access that data and bring it in to personalize the item for the individual, I think that really does achieve the goal of providing the student with the absolute best opportunity possible to demonstrate what he or she knows. In the medical scenario, there are also medical databases, open source databases that have de-identified, of course, data, and you can utilize that data as variable content in your item model. So figuring out how to really connect your AIG engine up with those authentic databases is key. System implications, I talked about this a little bit. I just mentioned, is the AIG technology embedded within the content management system? Ideally, yes. And I can remember presenting at ATP probably 2 or 3 years ago, and putting the idea out there that someday we will be able to go from AIG to automated test assembly to a linear or a computer adaptive test without humans in the loop. And I know that has lots of implications in terms of psychometrics and whatnot, but there is a system out there. Cavian has developed a system that I've just been introduced to recently that does have AIG embedded in the content management system, and it goes AIG to ATA, and it dynamically generates items and administers them dynamically to individual students. So you're not sitting there with a huge database of items. You're sitting, you've got all of your item models, and then you can generate the items on the fly. So more investigation needed there, but very interesting. I had no idea that someone had already achieved that. I think the other implications are what content areas are supported by most AIG systems. In my experience, been able to generate mathematics content, English language arts content, science content, medical content, but generating literary reading passages for K through 12, that is still an area. I know there's research going on in this area, but I don't think we've quite cracked that nut yet. And until we can generate content for all content areas, I think that we won't achieve that equity goal that NWEA has indicated. Last, just thinking about, it does cost money to develop a system yourself for AIG or to license a system from another provider. So what kinds of things should you be thinking about really to offset the cost of that licensing if that is the way you're going? You definitely need subject matter expert training. The type of content required, the systems out there may not yet generate content that is the type of content that you require. What's the purpose of the assessment? Formative, summative, licensure, etc. You got to think about that. How often are you testing? How big of a bank do you need, basically? And how often are you needing to refresh that bank based on your number of test takers? What are your content development processes in place? How do you have to re-engineer those perhaps? And then do you have a content management system? AIG tends to produce a lot of content. So you've got to have somewhere to store that content once generated. So all of those things are very interdependent and need to be really thought about as a collection in terms of coming up with your ROI for introducing AIG. And I believe that is it for me. So I'm going to turn it back to Pamela. Is that,
yep.
Are you next?
I'm next. Thank you, Donna.
Okay. So let me just make sure I stop here, and it should be back with you.
Okay,
Pamela.
let's see. Give me just a moment to get my screen pulled up. Okay, just a minute. Okay, are you all seeing the slides now?
Yes.
Thank you.
Mm-hmm.
Okay, let me just move some of these controls out of the way.
It's in the preview mode, so we can see your notes.
Okay, gotcha, thanks. Let me switch out of that. Thank you for letting me know. Okay. There we go. Getting used to Zoom over here. Hold on one second. All right, now we are ready to go. Okay, so moving on to my talk. So once again, welcome to this session this afternoon, and thank you for being here. My name is Pamela Kaliski. I'm a senior measurement scientist at the American Board of Internal Medicine. My two co-authors, Jerome Clauser and Matt Burke, wanted to give them a shout out. They were both very helpful in designing this study and giving very valuable feedback along the way as well. So the title of this presentation is Exploring the Utility of Semantic Similarity Indices for Automatic Item Generation. So I don't think we need to spend much time defining AIG with this group. So just a level set really quick. AIG we think of as a hybrid approach to generating items. It's a hybrid of cognitive theory, psychometric practices, and computer technology. So it differs from our traditional item writing framework where we're generating usually one item at a time by giving an item writer an assignment to write an item to a certain topic, one at a time. AIG is different in the sense that item models are used to generate many items at a time. So that draws a lot of people to AIG with the goal of getting more items in a faster time frame, or creating items that target the same cognitive attributes but still appear to be unique to examinees. So some terminology I'm going to use in this presentation because I know that in the field terminology can vary a bit. When I use the term source item, I will be talking about that as the generating item. So this is the item used to generate different versions of itself. In our study, this is an existing item that has a history of good statistical performance. When I use the term item variance, I will be referring to the items generated by the source item, so a new version of the source item, and an item model is the specifications for how to develop the item variance. So let me give you a bit of background into why we designed this study. So anything that is appealing often has challenges that come along with it as well. AIG is no exception. The particular challenge we were focused on in this study was that can be too many items and too little time to review all of them. So with AIG, with these item models we develop, we often get lots and lots of item variants, hundreds, sometimes into the thousands. And in that case, qualitative review from subject matter experts for all of those item variants won't always be possible. Similarly, data collection for all of those items won't always be possible. So we can't always get empirical pretest data for every single item variant that comes out of an AIG framework. So when we're faced with this too many items to review and pretest and too little time, how are we going to prioritize and pick which item variants we want to review and then subsequently pretest? There's only so many slots available to us, so we're looking for ways to help us prioritize how to manage all of these items that we get from AIG. The solution in the area we wanted to look into a little and explore was semantic similarity coefficients to help with this. So what are semantic similarity coefficients? These are coefficients that quantify the semantic similarity between two items. So there's a lot of description about various coefficients in the natural language processing literature. Some of them simply quantify how visually similar two items may be. Others are more complex and do a little bit more than just looking at the how similar the words are. Others get into more like the weighting of the importance of words. There's compositional distribution semantic models, and the index of semantic heterogeneity is a couple of examples of some of the more complex coefficients. Those are beyond the scope of this particular study. We were just focused on the cosine similarity index in this study, so the CSI. This is simply a measure of visual similarity between two items. So all you need to get the CSI is the text for two different items. Once you have the text for two different items, the CSI can be calculated without having any performance data or anything like that. So the value ranges from 0 to 1, and a value of 0 would indicate that there is no overlap between the two items, meaning there's no shared words. Whereas a value of 1 would indicate that the text between the two items is identical. The shared words in both items are identical. So this idea of semantic similarity indices in the AIG world has been explored and discussed, but there are not yet any interpretive criteria for cosine that would exist to sort of help practitioners really use this in this sort of phase of prioritizing which items they might want to review and pretest. So we know that it's a coefficient that ranges from 0 to 1, but we don't really have any sense of like, what does a value of 0.5 mean versus 0.9? Is there a certain value that would indicate that the items are too similar to be useful or something like that? There really isn't any framework out there for that yet. So the purpose of our study was twofold. First, we wanted to use feedback from subject matter experts to begin to establish some sort of meaningful benchmarks on this cosine scale. With the idea that these benchmarks might assist people with selecting which items to qualitatively review and then quantitatively pretest. So just sort of as a tool to help prioritize which items to move forward with. And our second purpose was to examine if any of these potential meaningful benchmarks we might learn from the first purpose, do they differ depending on the type of item model? So in our specific case, does the CSI differ in utility if the item model that's generating variants is generating variants that have a different answer key compared to the source item versus item variants that have the same answer key as the source item? So now let me tell you about our research study. We had a set of items that we used for this. We used 35 item variants that were generated from 4 unique source items from a board certification exam. So this graphic shows how many variants came from how many of these 4 source items. You can see we had 8 come from our first source item, 10 come from our second source item, 7 from our third, and 10 from our fourth. From this, we got 35 cosine coefficients computed, one for each pair. So I'm defining a pair here as the source item with each item variant. So it made for 35 pairs. So we had one cosine coefficient for each of these pairs. We had a subject matter expert task that we then designed, and we had 8 subject matter experts who were board certified physicians participate in this activity. So their activity, I'll tell you more about in a moment. It was focused on them evaluating each item pair and really looking at the uniqueness between the 2 items in the pair. Before we did the task, we piloted it with one physician so that we could get some information about reasonableness, make sure everything was clear, and we did not show the cosines to any of the subject matter experts. That wasn't part of their task, so at no point were they asked to use that information in any way. That was used for us behind the scenes. And I should also mention each subject matter expert that participated was trained first on the task. So now to tell you a little bit more about the task and which specific questions we wanted to ask them to answer. There were 2 specific questions we really asked them to focus on. The first question was about how substantively different these 2 items were from each other. So we asked them exactly that for each item pair. Are these 2 items substantively different from each other? They answered on the sort of Likert scale type of question, with one end being yes, they are completely different, or at the very other end, no, the items are not substantively different. And then they were given an opportunity to give some qualitative information as well after that they answered that question. So this was important to us because we wanted to know, are the items seen as unique enough to be considered, 2 unique items in the pool? If they were so similar to each other, we would want to be careful not to put them on the same form. The second question we wanted them to weigh in on was more about what would happen if we publicly released one item, what would happen to the other, would it survive in the pool? So specifically what we asked them was, imagine that the source item was publicly released and you encountered it while preparing for your upcoming exam. If you saw the other item, the item variant, would you be more likely to identify the correct answer without using your medical knowledge because you saw the source item first before taking the exam? And then they gave us an answer of either yes, they'd be more likely to know the correct answer, B was they'd be somewhat more likely to know, and C was no, they would not be more likely to know the correct answer. And again, they were given the opportunity to give some qualitative feedback after their response as well. So those were the 2 main questions we wanted to ask them. And the second one was really important to us because if you're living in a world where you need more items and you need to also release some of them after they're administered, we want to make sure that as we're releasing items, we're not putting other items in the pool at risk. Once we got these responses back from our subject matter experts, they were coded in this way shown on the slide. So the first question was coded from 1 to 5, with a 5 the highest value, meaning no, they were not substantively different. And the second question was coded from 1 to 3, with a value of 3 being yes, they'd be more likely to know the answer to the variant if they had seen the source item. So higher values that we saw would sort of caution us as to thinking maybe these 2 items weren't that unique from one another. Maybe one would be putting the other at risk if one was released. So in general, I'll explain more in a moment, but just know that higher values would be sort of a word of caution to us if we saw the higher values. So we had a flagging approach that we used to flag the item pairs after we got the subject matter expert responses back, analyzed that, and averaged it for each question. If an item pair for question 1 had a mean greater than or equal to 4, or if question 2 had a mean greater than or equal to 2.5, or if both of those applied, that pair was flagged. Okay, so this was somewhat arbitrary at first for us to find a way to flag these, but we then went back to the qualitative responses we had received to sort of anchor those to make sure that our cut points here sort of made sense. So sort of arbitrary, but it helped us sort of just get a general sense of if we wanted to flag certain areas or certain pairs as maybe being pairs we'd want to look into a little bit more. So let me show you the results and how we looked at this data when we got it back. Here's a scatter plot of the cosine similarity index and the average question 1 responses. So let me orient you to this scatter plot. On the y-axis here, we have the average survey 1 response. So again, these survey 1 responses ranged from 1 to 5, and the cosine is a value that ranges from 0 to 1. And the scatter plot then shows the relationship between these. So there's 35 points in this plot, 1 for each item pair. Now, what I would notice here by looking at this first is that there's this one cluster kind of up here at the top that would be a bit concerning to me, because all of these that are in this little cluster have average survey one responses that are higher. And like I said earlier, higher kind of is a red flag to us, as in like, are these two items not substantively different from one another? So those would be some we'd want to look into further before treating them as unique items, or we'd certainly at least be careful with not putting them on the same form. So that's the first thing that I wanted to point out here, is that little cluster might be a bit concerning. Now recall that the second research question of our study was to look at these pairs by whether or not the variant was written with the same key as the source item or different key. So we had this research question of same key versus different key. So if I show you the same graph, but break down which item pairs here were written towards the same key versus the different key, you can see there's a very clear pattern that emerged. All of those dots that are in orange were representing item pairs written towards the same key, with variants written towards the same key. So those are all of the items that were in that concerning cluster that I pointed out on the previous slide. So kind of gets to our second question, which was, is there going to be any sort of relationship between different key versus same key? And it's looking like there was definitely some sort of relationship there that was worth looking into. So that was the first question. Looking at our second question that we asked our subject matter experts, so this was the one about if they would recall the answer to one question had they seen the other one prior. So again, we have this sort of concerning cluster up here with this question. So these were all item pairs that had average survey 2 responses around 2.5 or higher. And once again, if we break those down by different key versus same key, those same key item variants all sort of comprise those that were in that concerning cluster. So very interesting to us that we sort of isolated that there are these same key versus different key effects when we were looking at the relationship of cosine to these subject matter expert responses. Now, another way I want to show you this data, and you don't need to worry about seeing these numbers clearly. I know it's a lot to put on one slide. This, what I'm about to show you is just going to give you a more holistic way of sort of synthesizing those flags that I mentioned earlier, and thinking about both survey questions at the same time, since I just showed you 2 plots for one at a time. So to orient you to this table, this column with SK or DK just indicates whether or not that row is for a same key or different key pair. You have your cosine value in the second column. This shows the range of cosines for all 35 of our item pairs, which range from 0.46 to 0.92. And then we have our mean values over here for each of our survey questions. Okay, so what I wanted to show you with this slide is if we layered on all those flags. So all the rows that are in pink here would indicate any row that was flagged. You can see that all the rows that are flagged are same key item pairs. You can also see, if coming back to understanding cosine, that nothing with a cosine below 0.7 was flagged. So potentially starting to point at a potential point on a cosine scale that might be useful. However, I think what is speaking loud and clear to us from this table is just that same key pairs were flagged, different key pairs were not. So let's just wrap this up with a little discussion and some observations. So the key observations here were that none of our item pairs with a CSI below 0.7 were flagged. So coming back to our initial first question is there any sort of meaningful benchmark on that cosine scale? It might be tempting to say, well, maybe 0.7 is somewhere around an area that we should be considering as meaningful. So maybe a practitioner would not want to move forward as fast with item pairs that had cosines above 0.7. You want to look into it a little bit more carefully. However, it's really hard to make that statement given what we found with our second research question. It becomes really difficult to disentangle cosine utility when we have the same key versus different key pattern here. So at the end of the day, if we really just found that variants that are written to the same key as the source item sort of become concerning and variants to the different key are not, that could be more the primary finding than cosine having a value of 0.7 being meaningful. So really at this point, it's hard to disentangle those two things based on what we saw. So definitely there's some steps for future research here to really dig into this more. This really seems like an initial first step at understanding what might be happening here and whether or not cosine could be useful. It would be really helpful to look at the same task with other disciplines other than the one we just looked at. So of course, generalizability is something we always think about. We only did this with one discipline so far. Would these results translate to other disciplines as well? Would we see the same patterns with the CSI and with same key versus different key? Like I said just a couple minutes ago, needing to better understand the cosine below 0.7 would be helpful as well. So we didn't see anything flagged below 0.7, but that doesn't mean that if we didn't have some more different keys or same keys below 0.7 that we wouldn't. So just collecting more data to understand that better would be helpful. Also needing to better understand the cosine above 0.9 would be useful. So we had a few item pairs above 0.9 here, but they were for same key item variant pairs. So understanding if that would look the same for different key, because as of now, nothing that was a different key was flagged, but is there a point where the items do become similar enough that even for a different key, they would be flagged is something that we'd like to look into more. All in all, I think needing to disentangle that CSI finding from the same key versus different key pattern is the most important finding, I think, coming out of this. And of course, as I mentioned earlier, this is all just applying to cosine. There's other semantic similarity coefficients out there that might have utility as well and incorporate more things like importance of words, things like that. So I think extending similar work to explore the utility of other coefficients would be helpful as well. So thank you for listening, and I will turn this back over now to Josh and Drew, our last presenters.
Thank you, Pamela. Let's see. So Josh and I did a little bit of look at what happens when we pre-equate forms using AIG items and kind of the implications of that process. So there are large changes happening in the field that I work in, which is medical recertification, maintenance certification, but there's also changes happening in the K-12 space as well with kind of the rise of formative assessment. In the medical recertification space, what we're seeing is a push towards longitudinal testing, which is, assessing every, couple months, every quarter, every year, constant assessment rather than once every 10 years, which is was the kind of gold standard for medical recertification assessment. Given these changes to the assessment landscape, what we're seeing is we need better and different item solutions, item development solutions in order to meet the item demands for these types of assessments. As soon as we place an item on a longitudinal assessment, what we see is that item becomes kind of exposed, and we constantly have to update and refresh that bank in order to keep examinees' knowledge current and up to date. Therefore, traditional item writing could be at its could be at its end. That's kind of a provocative statement, but we might be getting to the point where traditional item writing can't keep pace, or is going to be difficult for traditional item writing to keep pace with the number of items that we need in our item pools to make this work. Make this work. So one emergent solution, and I won't belabor this slide because you've heard 3 people talk about it so far, is automatic item generation AIG. This automation can be on the simple end. So from simple cloning strategies where we're taking elements of our items, modifying them, and that could be just as simple as the lead-in and the options, all the way to more advanced item solutions like assessment engineering, evidence-centered design was brought up. These solutions require a little bit more work and kind of thought into the items themselves with the goal of statistical isomorphism. Content isomorphism and statistical isomorphism are 2 different things that AIG can try to achieve. content isomorphism is simply, can we measure the same thing with a set of items? If I'm looking at one specific learning objective, can I create clones of that particular item to measure one thing and one thing really well? Statistical isomorphism takes that a step further. It takes it and it says, can I create content that measures the same thing at the same point in our scale? So can I measure at the same difficulty? Not only can I measure the same thing, but can I measure the same thing at the same difficulty or the same cognitive space? Examinees have a wish list that is long, and we are often pushed to provide them as much candidate-friendly policies as we possibly can. A couple that I've noted here on the slides: on-demand testing, so where I can test anytime, any place, anywhere. Fast turnarounds on score reporting, so we can't wait months to give them their scores. They want to know today, how did I score? And large amounts of feedback, formative feedback for unsuccessful candidates. Some of these features are kind of helped by pre-equated test forms. It helps us do on-demand testing. It helps give scores and feedback quickly. It can help, in some cases, provide formative feedback, but that's a little bit more of a reach. But what our study looked at is specifically what happens when we use AIG family level statistics as opposed to the true item statistics in order to kind of build these pre-equated score lookup tables. We had 18 item families, item models that we used for this study. They were on a large scale exam. Unlike the previous two presenters, Pam and NWEA's presenters, we did not use exemplar items. We built these from scratch, which was sometimes great and sometimes a little bit difficult, but we managed to do it. But these models were new items that were not based on a single exemplar template. We were not trying to build items that had statistically the same thing as we went along. We had a group of new item writers, a group of folks who were interested in AIG but hadn't necessarily written items for us. They covered roughly half of our first level blueprint nodes. So I think we have 14 or 15, and I think we got about 6 to 7 to 8 first level blueprint nodes covered with these item models. In order for us to kind of build like forms and do this study, what we did was we duplicated the models, gave them different blueprint nodes to simulate having more coverage of the blueprint from each model. This is a wall of numbers. What I want to point out, it is sorted in item variance order, so or model variance order. So the first few models receive a standard deviation of our B parameters or our difficulty parameters of under 0.3. Which indicates a pretty tight fit on difficulty on our scale. As we progress, we see some under 0.5. Roughly half of the models were under 0.5, which is still not the worst. As we continue up, we see greater amounts of item variability, family variability in the items that we pretested. We have roughly 6 to 7 items. One could ask, is that enough? And you'd probably be right in asking that question. We may want to get, the more questions we ask, obviously, the lower variance we'd have. Each form was constructed with 100 items total. We had a kind of a 0 as our base reference group or a reference to see how, just without any AIG items, how well do we do. But then we had 5%, 10%, a quarter of the exam, and half the exam kind of built with AIG items with predefined item family statistics. We, of course, built these forms to match blueprint and information targets. We tried to treat it as if we were going to build lots of 100-item forms for our assessment using automated test assembly. After we did the automated test assembly, we generated lookup tables. Again, we had some psychometric or some traditional items with true statistics. We also had our family AIG items with family statistics. We combined those. We built lookup tables for a raw to theta equivalent. Like I've said a number of times, we use those family-based statistics rather than the true parameters to build these tables. So we simulated for 5,000 examinees. We did with replacement from our operational exam distribution, which tends to be, and I think this is also probably true in general of medical recertification exams. High ability, very tight ability. You see a very peaked distribution, one that's much more able than your item where your items are. Given that, we set a cut score at about the 15th percentile, which is consistent with certificate licensure testings as a whole. We thought, I did a little bit of research. It seemed like on the lower end, you see about a 20% first-time fail rate. On the high end, or on the high passing end, you see about a 1% fail rate. So we chose 15%. It seemed about right. We then just compared the true theta to the cut score that the score from the lookup table to the cut score, and determined their passing status based on that comparison. We ran this each condition 50 times. We looked at a couple of different fit metrics. First, classification accuracy, where we just want to say, okay, your theta suggested you should pass. Did you pass or not? Your theta suggested you fail. Did you fail or not? See how well we do at just classifying people into pass-fail groups. We also looked at score bias. Just, was there a difference in score bias? And then how well do we do at recapturing theta as a whole? Unpacking this table, the first thing that jumped out to me was the correct classification rate. I work as kind of the head of the AIG project, and so I was like, hey, look, AIG items are fantastic. We see a greater correct classification rate when we see more AIG items. Why don't we just have an entire form? It'd be like 100%, right? Unfortunately, Josh pointed out that score bias has probably a lot to do with that. We see a positive bias. AIG items tend to be easier, or there tend to be more easier items compared to the model statistics as the whole. We see skew in our AIG model statistics. Therefore, we see positive bias. Also, RMSE tends to go up a little bit as we climb from no AIG items all the way up to half of the exam being AIG items. To me, that's encouraging. 0.02 feels good, but if you're that person who has the 0.02 on one side of the cut score or the other, you might be a little annoyed with me if we do this. I will also note that false positives in medical recertification are usually not considered a good thing. So being conservative, we might also have a handful of false positives in there as more because kind of everyone's score estimation was pushed up due to that positive bias. We saw this as just as a first step towards the evaluation of AIG family statistics on our equated test forms. Given that these were the first AIG models that made it on to exams, we wanted to see what would be the effect if we scored in this manner. Would it be okay? Would it not be okay? I do think that the error increase is fairly small, and that's a positive sign. The score bias, on the other hand, is troubling, and I think we would need to ensure that we weren't passing examinees that had not truly met our performance standard. Also, if we looked back at that table that I displayed earlier with the 18 models, several of those models had really high variances. Just as a comparison, if we looked at all the other items on our forms and we did a little comparison of the variances of just traditionally written items versus the variances of AIG items, what we'd see is that there were a handful of items that were more variable than if we just wrote items just willy-nilly and they had no relationship to a family. So those that we would definitely want to take a look at, figure out why we see that variance, and kind of make efforts to constrain it if possible. So some of the next steps that we're going to explore is we're going to look for some maximum allowable variance criterion that allows us to say, hey, we need items that don't see this large jump in bias. Can we constrain our variances in order to select families that meet a certain criterion? And if we can do that, when the bias drops, then can we then treat that family as kind of having a lock space on the scale? We also want to determine the number of items required to estimate family statistics. Like I said, we only use 6 or 7 items per family in order to estimate these statistics. In some cases, that felt about right. In others, it was not right. Combining that with some efforts, Pam's talk kind of hits on this point of, can we work on figuring out items that have similar characteristics, similar distractor sets, items that feel similar to content experts, mine that and come up with a metric and a criteria for, if we do see lots of variance, can we identify the factors that make items different and then thus constrain the difficulties of those items within family. If you have any questions for us and don't feel like speaking up, feel free to send either Josh or I an email. Thanks. Turn it over to Hollis.
Hollis, you may be on mute.
Now we've played Zoom bingo. All right. So thank you very much, everybody, for presenting your papers as you go. I think as we went through, we wanted to kind of, one of the process of how I kind of sorted all of these sessions together was really about how impressed I was with looking at how the AIG has kind of progressed in the past decade, and we've gone from proposing a method down to proposing how we go about to operationalize it, and now we're mostly dealing in the test development practices and how to make use of all of the AIG outcomes that we have. So I want to look into the the various some of the pieces from business, and that's where the innovation, the fusion of innovation theory, where people are obviously people are mostly familiar with the innovation curve in terms of the innovation adoption curve, and the reason I want to bring this theory back up is this model kind of distinguishes how disruptive innovation and sustaining innovation has different needs and requires different solutions in order to kind of provide something to meet the needs of AIG. When it comes down to it, the development of AIG really is beginning to take 3 different perspectives. Sorry. The AIG is beginning to take up the adopter, where there are people that are constantly working on the improving the technique of generation, as well as innovating on top of the test development approaches, which is the experimenter. They've already thought that they want to adopt AIG, but they want to tinker around with it to make sure that they're confident with its ability in producing test items. And then it comes down to the producer, which is how do you bring this back onto and integrate this into sustainable test development practices? I think our goal in the work that Mark and I have done has always been focused on how do we bring that down to the sustainable test development practices. And I think that this talk really focuses on appealing to that early majority adoption, where a lot of the solutions proposed here really is trying to adopt and address the issue that AIG is trying to come across. And I think that's there's also the NWEA solution that's also proposed a little bit earlier in the forefront as well. I think when it comes down to Kilisi's paper, what I've noticed was that, cosine was obviously a good choice. We've used it in the past to kind of look at how we go and quantify the similarity of items. It was a kind of like a Goldilocks approach on whether or not it was good, but at the same time, that was only we started using CSI only because we didn't have a knowledge base that was available. And if you are looking for semantic distances, you may want to have a look at UMLS. I think that might be helpful. It takes quite a while. We tried it before, and it's better than any word nets that are out there because of the medical terminology that they have. But there is a process that you can go about to kind of go through and evaluate its semantic distances through that database. I think your suggestion for looking at the cut of 0.7, I think it's pretty bold, but I think what you've presented in the data really is suggesting whether or not the same key or not seems to be more important. I had a couple of suggestions, which was, what if you take a CSI from the item family? So I think you had it on a pairwise basis. If you've kind of done all the possible CSI permutation from each other, and then you kind of look at how a specific pair differs from the distribution, maybe that relative comparison may help you in determining whether or not it's different enough. Just a thought. If you're model-based like us in terms of generating the items, then would you consider running the cosine based only on the variables rather than all the words used? And the third part was modeling for linkage or validation is expected. So it may be helpful to kind of use that information from the generated set to kind of instantiate how that information can be used to validate the differences as you have. When it comes to Dallas and Goodman's paper, the focus really was looking at evaluating the effects of pre-equating. I think the item family approach is great. I think that you're going to get into the as we move towards competency-based education in I think all of the health professions. I think it's coming. I think the item family, the item family estimate approaches, I think would be more and more relevant, because I think that's where a lot of the KSAs, a lot of the competencies will be kind of grouped together, and it will be difficult to kind of determine and distinguish how the concepts are different from one another. So a concept may have a difficulty estimate, item family estimate, of which items may be written, may be generated, that kind of generates, that kind of provides an estimate. So I think the approach using that as a foray for figuring out the pre-equating form differences, I think it's great. I would consider looking at Kilisi approach. I think some of them, we obviously looked at those semantic differences before using CSI and other measures, but I think the similarity indices may help with figuring out where the differences lie and how different each of the concept or item families are in order to kind of minimize the level of variation in your estimates within the family. I think Donna's paper really is a position paper that that explains all the challenges in bringing the AIG into operations. And, you know, obviously the Pepsi test is very convincing in terms of getting test developer buy-in and using AIG. But when it comes down to it, you know, there is a very robust change management process that's needed, that's often forgotten in thinking that AIG is a software. And yes, the software is available. And but there is a mindset and there is a training approach that needs to kind of get acclimated with the cognitive modeling process and and all the various types of changes that's downstream that needs to be facilitated. And adoption of technology sometimes just takes time and validation. You need more evidence for validation, and you need more time to kind of adopt those methods. So when it comes down to the NWEA folks, I think that was fun in terms of using the Excel VB script to kind of power through the template-based approach. I think you run out of legroom in terms of being able to adopt the flexibility of that very quickly. But I see that, in your paper, you describe a very comprehensive and robust proposal. I think that's the OCR approach. I didn't really understand why you wanted to scan and do OCR to kind of build your knowledge base. I think all the other pieces seems to fit with how curriculum management and content management kind of works currently. I think it's an ambitious proposal, but it's kind of building on top of what Guido and I think Ha has actually proposed before, with an OCR layer on top, and that's where I think you're going to run into. I think you're going to run into some difficulties in terms of the conquering that OCR part, but I'm sure that's it's because you probably have a lot of existing information in paper form, and that's why you need to kind of provide that in an OCR approach as well. I just want to come back to some of the concepts that we've kind of presented before. As we kind of go down different paths of AIG, we really have different approaches towards how we go about to generate the items. When you're providing solutions that are very specific, then you increase your programming needs. But then the more generalizable your approach is, then you need more prior knowledge in order to kind of go through that, in order to realize that approach. So on the left and the right-hand side, those are the alternative paths that we never really took. Knowledge-based approaches takes too much to assemble a knowledge base. Programming instruction approach is too specific. So we kind of went down the path of using the logical constraints and cognitive modeling approaches, now available through ACT. But I think from some of the discussions that from our presenters here, you may want to consider that the assembly process for putting the items together, whether you use machine learning or graph theory or whatever it is that you have on hand, is independent from the approaches, which is described in those 3 directions that I have up here that are taken. And when it comes down to it, picking the modeling process and the assembly process may actually help with your testing needs. The reason we picked our approaches, which combines cognitive modeling with the Igor assembly process, was because it matched closest to what we thought the test development process was. It minimized the amount of change management that we would require. So, for example, test developers don't need to learn too much about programming, and the various technical requirements that will be required to build up such a generation engine. And these resources are now commercially available through ACT and other vendors. So when it comes down to it, the summary of the challenges that I think the presenters have highlighted is that adopting AIG is going to be, it's a human challenge for how you go about to do change management. But as some of the presenters have already mentioned, what is your alternative? Your alternative is getting back to item writing, and that's not sustainable in any way. So I think some of these solutions, item generation solutions, are here to stay as complementary to the curve and as complementary to the tools that they would have available. Evaluating some of the outcomes, AIG outcomes, would be also very important as well, in terms of, I think more and more you'll look at different psychometric properties as well as similarity indices. Those are all pieces of information that I think we would be able to leverage in order to better organize the content and the concepts that we're assessing. And finally, improving the AIG methods. I think more of these NWEA approaches and more kind of kind of paradigm shifting approaches is needed, and we need to kind of keep continuing that approach because, you know, I think that template approaches works, but at the same time, we do have KB approaches that are available. But minding the difference in between the transition in between disruptive innovation, which is usually bringing research into reality, and a sustaining innovation, which is bringing test development practices, improving test development practices. And I think those have different needs and they require different solutions. So thank you very much.
Great, thank you, Hollis, and thanks to all of the presenters for participating today. We kind of ran up against our time here. Thanks everyone for dealing with technical issues, and it sounds like I presented with my notes showing the whole time, so I apologize for not having anything more exciting in my notes to share, but thank you for being patient during that. Anyone have any questions? Audra, I just saw a question from you in the chat, and I threw a reply in there. Is there anything else anyone would like to ask, either in the chat box or if anyone would like to come off mute one at a time? We probably have time for one question. It's 3:29. I know that all of us would love to have more conversations about this, so please feel free to reach out to any of the presenters to continue these discussions, answer any questions that might come up that you might have later. And once again, thank you all for being here today, and hopefully we'll all see each other in Baltimore next year. Thanks a lot.
Thank you, everybody.
Have a good day.
Thank you.